So today we have a nice geometrical theorem. The diagram is on the screen and you can see that how beautifully a circle is inscribed inside a semicircle with help of a right angle triangle. Now because of this arrangement there comes a theorem that defines a relation between the sides of the triangle and the radius of the circle. So if I take the radius of this circle as A and the hypotenuse of this right angle triangle as M and base of this right angle triangle as N, then the relation is A would be equals to M minus N. So this is Anmol Mishra, and now let us see the solution. How can we prove this particular theorem? So first of all, I will draw a line segment joining the points D and C. Now look carefully that the angle ADC is inscribed inside a semicircle. So as per the theorem, we know that angle inscribed inside a semicircle is 90 degree. Therefore the angle ADC would be 90 degree. Okay. Now we can use two methods to move forward in the solution. So the first method is either using the trigonometry. So what I will do is I will simply take the angle DAB as a variable equals to theta. So look in this right angle triangle, that is the triangle ABD, it's a right angle triangle. So in this particular triangle the value for cos theta would be equals to n upon m, that is the base upon the hypotenuse. Now again look carefully that the triangle ADC is also right angle triangle and it also contains theta as its angle. So in the triangle ADC the value for cos theta would be equals to the base, that is m upon AC, that is the hypotenuse. Okay, so now we can compare these two ratios. So we will get n upon m equals to m upon AC, and from here the value for AC would be equals to m square upon n. Okay, so this was using the trigonometric method. So this was the first method to get the value for AC, that is m square upon n. So the other method to get the same thing is similarity. So carefully take the triangle ADC. In this triangle angle A is theta and angle D is 90 degree. Now take the triangle ABD. Again in this triangle angle A is theta and angle B is 90 degree. So here we have two triangles in which two angles are equal. This means these two triangles are similar by angle property, and also the labelings of the triangle has been done according to the correspondence. So we can simply take the ratio as they have now become similar. So AD upon AB would be equals to DC upon BD, and this thing would be equals to AC upon AD. Now we can simply replace this thing with their variable values. So AB is having a value N, the value for AD is equals to M, and this thing is equals to DC upon BD. Now the length of DC and the length of BD is not in variables, so we will not compare that ratio, and the final ratio is AC upon AD. So the length of AC as it is and the length of AD is again equals to M. So from here we will again get the value for AC as equals to m square upon n. So you can see that we use two methods to get the value for AC, that is m square upon n. Now you might be thinking, what is AC that we are doing two methods to find its value? So look carefully that the length AC is from here to here, that is ultimately the diameter of the semicircle. So using two methods what we got is actually the diameter of this semicircle. Now as we have got the diameter we can find the radius by dividing both the sides by 2. So let this point, that is the center of this semicircle, be equals to a point O. So the length of OA, that would be equals to OC, and that would be equals to AC upon 2, that's the diameter. So from this both equation we have the value for AC, that is m square upon n. So this thing would be equals to m square upon 2 times n, and that is ultimately the radius of this semicircle. Okay, so here we have got the radius of the semicircle using this right angle triangle. Now let us utilize the things related to the complete circle. So as it was given the circle is tangent at these three particular points, so we can utilize that thing. So we can see that the circle is tangent to the semicircle internally, and we know the theorem that if there is a circle and there is another circle that is tangent to it either internally or externally, the center of that circle, the center of the bigger circle, and the tangent point would be in a straight line. Similarly with the internal case, the center of the bigger circle, the smaller circle, and the tangent point, all these three would be in a straight line. So the same thing can be applied over here. We have the semicircle and there is a circle that is tangent to it internally. Therefore, the center of the semicircle, the center of the circle, and tangent point in a straight line. Okay. Now let this point be the point P, and let the center of the circle be marked as the point S. Okay. Now look carefully that the length from O to P is radius of the semicircle, that is m square upon 2n. For now, let it be equals to a variable r. So the length from O to P is equals to r. The length of S to P is equals to a, that is the radius of the circle. Therefore, the remaining distance, that is O to S, would be equals to longer minus the shorter. Longer is r, shorter is a, therefore OS would be r minus a. Okay. Now this angle over here is 90 degree. Let this point be the point K. So the length SK is the radius of the circle, and this angle is 90 degree because it is the tangent point. Now what can you say about the length of K? So let me just remove this r minus a from here. Now as this point is also a tangent point, so if I draw a radius, the angle over there would be 90 degree. This distance would also be equals to a. So here we form a square because all the angles are 90 degree and adjacent two sides are equal. So in a square, opposite sides are equal, therefore the length of BK would be equals to A. Now using this data, we can easily find the value for OK. So let us see that. So what we need is OK. The length of BK we have. So look carefully that O is the center of the semicircle. So from O to A, the distance would be equals to radius. So that length would be equals to R. From B to K, the distance is equals to N. Therefore the distance of OB would be equals to N minus R. Now what we need is O to K. OB is having a distance n minus r, BK is having a distance a. Therefore, the ultimately length of OK would be n minus r plus a. So here we have got the base of this triangle. The height of the triangle is already a, and the hypotenuse of this triangle was equals to r minus a. So we can simply apply the Pythagoras theorem. So the triangle is like this: the height, the base, and the hypotenuse. There's the 90 degree. The height is a, the base is n minus r plus a. So remember the value for r, that is m square upon 2n, and plus a, this is the base, and the hypotenuse is r minus a, therefore m square upon 2 times n minus a. Now in this triangle, let us apply the Pythagoras theorem. So as per the Pythagoras theorem, the height square plus the base square, so n minus m square upon 2 times n plus a, the complete square, to be equals to the hypotenuse square, that is m square upon 2n minus a, the complete square. Now let us simplify this thing. So a, the complete square, becomes a square plus this, the complete square. So what I will do is I will simply take this thing as one bracket and this thing as the other. So a square plus n minus n square upon 2n, the complete square, plus 2 times a into n minus m square upon 2n. The identity for a plus b, the complete square. I took this term as b and this complete term as a and applied the identity. Okay, and this thing is equals to this, the complete square. So m to the power 4 upon 4n square plus a square minus a m square upon n. So again we have two brackets to be open, one over here and one over there. So a square plus a square plus, opening this bracket, so n square plus m to the power 4 upon 4n square minus m square plus 2an minus am square upon n, and this thing is equals to m to the power 4 upon 4n square plus a square minus am square upon n. Now here we can see that positive a square got cancelled out, negative am square upon n, negative am square upon n got cancelled out, positive m to the power 4 upon 4n square, positive m to the power 4n square got cancelled out. So on the right hand side we completely have 0, and on the left hand side what we have is a square plus n square minus m square plus 2an. This, and this term, and this thing is equals to 0. Now I will simply shift the negative m square from the left hand side to the right hand side. So on the left hand side we will have a square plus n square plus 2an, and this thing is equals to m square. Okay, now carefully see that on the left hand side we have the identity a square plus b square plus 2ab. So this can be written as a plus n, the complete square, and that is m square. From both of the side we can just take the square root, so we will get a plus n equals to plus or minus m. Okay, now we will get the value for a as equals to m minus n or else negative m negative n. Now this cannot be taken in consideration because a is radius of a circle. It should be a positive value. It's a distance, so it cannot be negative. So we have to go with this value only, that a is equals to m minus n. And remember, the thing to be proved was a equals to m minus n, and we actually did it without using trigonometry. We used trigonometry over here, but that was just a method. I've showed you that we can even use the similarity to get the value for AC, and then we just applied the Pythagoras theorem. This means you can prove this theorem even without trigonometry. So this was a very nice theorem. You can see that a beautiful arrangement can lead to a beautiful relation between the side length. So this is my way to solve this particular question. If you have any other method other than this, to comment below, and if it's hard to comment, you can email me, or else you can send it to me on my Instagram. The link is in the description.